Hello. This video will demonstrate the stacking of product on a moving conveyor using a motion that's sometimes called move on a gear. We'll explore the steps involved in this operation, and along the way I'll explain why it's called move on a gear, even when no gears are involved at all. First, let's take a look at the complete sequence of events in real time. A vacuum picker grabs all 8 workpieces, shuttles them over the moving conveyor, places 4 of them, then shifts forward to place the remaining 4 on top of the first set. It looks simple, but there's a lot going on here. In addition, ideally you would want everything to stay in sync, even if the conveyor is stopped or slowed for some reason. So let's break down the sequence into a series of steps to get a better idea of what's happening. The first step is easy enough. We move the shuttle over the supply station. Then the vacuum cups are lowered to the pickup position, with the vacuum turned on when the cups are in position. When vacuum is established, the cups are raised to a clearance position for the shuttle move. The shuttle then moves into position over the conveyor at high speed. It will now synchronize with the conveyor, matching its speed. In this operation, the shuttle is actually following a position on the moving conveyor. This can be useful if, for instance, the workpieces must be accurately placed in a nest on the conveyor. To save time, note that the vacuum cups start lowering at this point too. Here's where things get fancy. Half of the vacuum cups release. All during this period, the shuttle is kept synchronized to the conveyor, so the depositing of the workpieces is a smooth process. The vacuum cups rise, with the shuttle tracking the conveyor so the remaining workpieces don't hit the deposited ones on the way up. Once we're clear of the deposited workpieces, here's where the move on a gear operation takes place. First, though, a word of explanation. In motion control, gearing refers to synchronizing 2 or more axes of motion, just as though there were mechanical gears connecting them. That's what we've been doing between the conveyor motor and the shuttle. They've been tracking each other perfectly in a relationship we want to maintain. Now, though, we want to advance the shuttle a fixed amount to position the remaining workpieces so we can stack them on the ones already placed on the conveyor. This additional motion on top of the so-called gearing already taking effect is called a move on a gear. So here it is. With our move on a gear now complete, we can lower the vacuum cups to a position where the remaining workpieces may be stacked on the first set, still tracking the conveyor with our original gearing relationship. Finally, the remaining vacuum cups are released and raised, and now the shuttle may be returned to a home position or back to pick up another set. So now, let's take another look at the complete sequence. The original application this animation is based on involved a number of additional complexities, including tracking of data relating to each workpiece throughout the process, and the control and coordination of upstream and downstream functions. And as mentioned earlier, the use of a gearing approach throughout this motion sequence allows the conveyor to be slowed, stopped, or even reversed, with all associated motions and operations remaining in sync throughout. The control hardware used in the application is a Control Technology Corporation Model 5300, equipped with an EtherCAT Master Control Module. This system supports the handling and tracking of the associated product data, as well as interacting with a remote database. And CTC's EtherCAT implementation supports the full range of motions used in this application. The use of EtherCAT, an open standard for motion and remote I/O over conventional Ethernet wiring, greatly simplified the wiring of the system and provided a broad choice of motor drives for the various functions being performed. To learn more, or to discuss your own particular requirements, contact CTC's application specialists at 1-800-282-5008. Thanks for watching.